So this video is all about finding missing lengths or missing angles in right-angled triangles. Okay, so we're looking at trigonometry, or SOHCAHTOA as people call it. And I go through three different situations or three different scenarios. Two where we're finding missing length, and then one where we're trying to find a missing angle. You can see them on screen there, so you can just jump to the particular bit that you need. But also you can practice these questions, and I've put a bank of other trigonometry questions over at mathskitchen.com, and there's a link to that in the description below as well. So let's get started on the first question. So in this question, we're being asked to work out the length of x. Well, the first thing to notice is that we've got a right angle triangle and we've been given one length and an angle. So when you've got a right angle triangle, you can sometimes use Pythagoras' theorem to help you to find a missing length. That's if you've got two lengths and you're trying to find a third. Now that's not the case here. Here we've got an angle and a length. So we're going to use trigonometry. We're going to use trigonometry in right angle triangles. That's the SOHCAHTOA stuff, okay? Let's have a look at how we can do that then. So now there's lots of different ways you can approach this, and it will all depend how you've been taught and what you've practiced. I'm going to go through my method, but I think whichever method you use, the key is to practice it a lot and to get into a routine of doing the exact same thing every time. Let me show you how I do it. First thing I do, I label my triangle. So this length here is opposite the angle that we've been given. This length here is adjacent to the angle that we've been given. And this length is the longest side of the triangle. It's opposite the right angle. So that's the hypotenuse. So we've labeled our triangle. Then I remind myself, I just write down, make a note of SOHCAHTOA, SOHCAHTOA. Then I've got to choose which of those I'm going to use. So the relevant bits that we've been given here, we know what the hypotenuse is. That's there. And we are trying to find the adjacent. So the two relevant lengths are the hypotenuse and the adjacent. Well, which of the SOH, or TOA contain the hypotenuse and the adjacent? In other words, an H and an A. And it's this one. That is the only one that contains an H and an A. That C at the beginning stands for cosine, or cos, as is written on your calculator, as we say for short. And that is the one we're going to use. Right. Next thing, let's make a note of our little formula for this. So the cosine of your angle, which is using that symbol theta there. So the cosine of an angle is equal to the adjacent. I'm just going to put A for adjacent over hypotenuse over H. I've just written there. And they're always written in this order. It's the first of, well, so you've got the sine, for example, would be opposite over hypotenuse. It's the O over the H. Tan, that one at the end there, would be tan of your angle. Tan theta is equal to the opposite over adjacent. It's the O over the A in that case. So it's that first letter after the S or the C or the T over the second one. Right, so that's that. Then I'm going to plug in the actual values that we've got. So we've got the angle is 45, so 35. Cos 35 is equal to, we don't know what the adjacent is, that is x. That's what we're trying to find out, and we know that hypotenuse is 6. So we're getting close now. All we need to do is to rearrange this a little bit. We want that x to be on its own. We're trying to make x the subject of this. So if I multiply both sides by 6, that's going to look like this. So let's make a note there. We're going to multiply by 6. Multiply both sides by 6. We will get 6 times cos 35 will be equal to x. Then we'll go to our calculator. We'll work out what that is, and we can type it in just like that, 6 cos 35. We'll put some brackets around the 35. That's what your calculator likes you to do. And that gives us 4.9149, and so on. We're being asked to give our answer to 2 decimal places. So x to 2 decimal places is going to be 4.91. work out the length of x and give your answer to 2 decimal places. Okay, so we have a right angled triangle. We've got one angle and one length. So that tells us we're going to be using trigonometry, or SOHCAHTOA, you might know it as. And it really is a good idea with these just to have a routine, set thing that you go through the exact same way each time. It doesn't matter too much how you set it out. I mean, you certainly don't have to do it the same way that I am here, but have a good, neat, clear way of doing it and just go through that same thing each time. Let me show you my process. So the first thing I do is to label the triangles. So we've got our 38-degree angle there. This 7 centimeter side, that is opposite the angle. X, that's the one we're trying to find out. That is next to, adjacent to the angle. And then the longest side of the triangle, the hypotenuse, opposite the right angle there. So that's the first thing. I label that. Then I remind myself, just make a note about SOHCAHTOA. SOHCAHTOA, and I use this to help me decide which one I'm going to use. Is it going to be sine, cosine, or tangent? So the two relevant bits of information here are that we know the length of the opposite side, and we want to know the length of the adjacent side. So we've got opposite and adjacent are the two relevant lengths. And so we look at SO, CA, and TOA, and we look to see which one of those contains the opposite and the adjacent, or the O and the A, just to take their initials. And it's this last one here, it's the T. So the tan of an angle is equal to the opposite over the adjacent. So let's make a note of that as well. So TOA, that means that tan of our angle, or tan of any angle, I'll just use this symbol here, that's theta. So tan of an angle is equal to the opposite, I'll just put O, over the adjacent. Once I've got that, I'm just going to substitute in the values from this particular triangle. So tan 38 is equal to, we know the opposite is 7, and we're trying to work out what the adjacent is, so that's the x. Now I've got a little bit of rearranging to do to solve this question. I want to get that x, the unknown, out from underneath that fraction, so let's multiply both sides by x. Let's make a note of that there, multiplied by x. It's strange having to write multiply by x. Never looks very clear, does it? And then let's work out what that is. So we will have x times tan 38 is equal to 7. I want to rearrange to get x on its own, so I'm going to divide both sides by tan 38. Oops, divide by tan 38. Make a note of that there, divide by tan 38, just about fits in. Let's write that down then, so x is equal to 7 over tan 38, and just go to your calculator, work out what that is. So if you've got a Casio calculator particularly, use that fraction button, 7 over tan 38. And the question is, don't forget your brackets there at the end. The question is asking us to round this off to 2 decimal places. So it's 8.95959 and so on. But to 2 decimal places, x is 8.96. That's your answer. So in this question, we're being asked to find the size of angle x, and it's in a right angle triangle. That tells us that we can use trigonometry, the SOHCAHTOA stuff. Okay, so we just go through our routine for solving these. Yours might be slightly different. You know, the way you set it out may well be different to me, but get your routine and have a good, clear way of working that out and of setting out your workings, and just get used to going through that routine again and again. That way you're less likely to make a mistake in the exam. Okay, so my routine is this. The first thing I do is to label the triangle. So the opposite side is the side that is opposite that unknown angle, the angle that we're trying to find out, angle x. Okay, so the opposite side is there. The hypotenuse, well, the hypotenuse is always the side that's opposite your right angle, in other words, the longest side of your triangle. And then this side here is next to the angle, it's adjacent to the angle. So that's your adjacent. And then we use SOHCAHTOA. So I'll just write that down there. SOHCAHTOA. Now we've been given two lengths here. We've been told the hypotenuse and the opposite. So those are our two relevant lengths, the hypotenuse and the opposite. So which of our trigonometric ratios includes the opposite and the hypotenuse? It is this one, because this contains the O and the H. It's the only one that does contain the O and the H. Let's make a note of that then. So sine theta just means the sine of your angle is equal to the opposite over the hypotenuse. And then let's substitute in the values that we've got. So we're trying to find this missing angle x. So let's change color. So sine x is equal to the opposite, which is 7 over 9 over the hypotenuse. Now we're trying to find a missing angle. So far, everything I've done is exactly the same as you would do if you were trying to find a missing length. I label the triangle, SOHCAHTOA, make a note of the little formula, substitute your values in. But when you're trying to find a missing angle, this is where it's slightly different. You have to use the inverse sign. It's that to the power of -1. When you're doing it on your calculator, you have to use the shift button. So that's going to look like this. X is equal to inverse sine of 7 over 9. Type that into your calculator like that. If you're using a Casio calculator or lots of other calculators now, actually, you can write fractions in. It makes our lives a lot easier. But don't forget shift and then sine, or maybe second function and sine, depending on your calculator, of 7 over 9. Close our brackets, and that gives us 51.05755, and so on. The question asks us to round to 2 decimal places. So x is 51.06 degrees. That's our answer. That is it. Everything you need to know about trigonometry in right-angled triangles. It is one of those skills where, because there's quite a few steps to it, it's really important to have a routine that you just follow, and you're into the habit of just doing the same thing every single time. So that comes from answering questions. You can do that over at mathskitchen.com. I've put a whole bank of questions. The link is down in the description below. Thank you very much for watching. I hope you found it useful. If you did, it would be really appreciated if you could give the video a little like or subscribe to the channel, and why not have a look at some of the other videos while you're here.